Alright, the Pythagorean triples are just set up to make things easier. You can always do the Pythagorean theorem if you don't remember your Pythagorean triples. But like I said, eventually you're going to want to know them because it makes your life a lot easier, especially when you get to trig functions. And you're going to deal with a lot with triangles in other classes. Alright, so the first thing I'm going to do is I'm going to take this guy down to its basics to see if it's a Pythagorean primitive, because I don't want to memorize that whole table. I just want to be able to remember just like 4 sets of numbers, and that means I'm just going to break this down as far as possible. So I'm going to set up a similar triangle. And I'm going to look for a number that goes evenly into 34 and 16. Well, that's going to be 2. So 34 divided by 2 is 17. 6 divided by 2, or 16 divided by 2 is going to be 8. Is there a Pythagorean triple that has 8 and 17 in it? And if so, what's my missing side on that triangle? No?
15.
It's going to be 15. Does that mean x is going to be 15? Yeah. What are you going to...
I was going to ask if we find like 1634, the other one would be 30.
Yep.
So can we say x is equal to 30?
If you recognize the 1634, that's fine. It's just, you know how big that table was? You have to memorize all those values to be able to do that. So sometimes it's just easy to remember those first couple primitive ones. And maybe I just remembered 8, 17, 15. But that would make this 30, right? Yeah, but you could jump right to 30. Yep, if you just saw it in your head, you could say x equals 30. Otherwise, you can say, well, 17 times 2 equals 34. 8 times 16, or 8 times 2 equals 16. 15 times 2 is going to be 30. So either way, either you recognize the 1634, or you break it down to a similar triangle that you can see the primitive primes on. Your choice. And at the end of the day, if you completely forget, if you're on the test and you're like, 8, 17, was it 15? I don't remember. You can always just go back to the Pythagorean theorem, where a squared, so 16 squared plus x squared equals 34 squared. Then you can do the work. These triples are just to save you some time, if you see the pattern. Alright, today we're going to talk about the geometric mean. And what we're going to use the geometric mean for is, you remember on the test, that last test where we had a bunch of drawings like this, where we kind of had to redraw the triangles and then come up with what's similar. We're going to use the geometric mean to actually solve these a lot quicker than having to redraw triangles to try to visually see what stuff looks like. So it's going to be kind of a shortcut for us whenever we have an altitude. But first we got to talk about what the geometric mean is. So recall that a proportion is an equation in which 2 ratios are equal to each other. We solve proportions by cross multiplication. In other words, we do our extremes times each other, and we multiply our means times each other as well. What a geometric mean is. So a geometric mean is when the means of the proportions are the same. So the means of a proportion are the same. So that means these two numbers are the exact same. That resulting number is called the geometric mean of the extremes. All right, the two numbers that are not the same. So we have two numbers that are the exact same, and then we have two numbers that aren't the same. So what it might say, what a question might say is, find the geometric mean between 8 and 10. Our geometric mean is that number that links these two things together in proportions. So if I want to find the geometric mean between 8 and 10, all I do is I write 8 is one of my extremes, 10 is the other, and I just got to find that missing link here, which is always the same number. So these are always the same number. This is always the same number. All right. So we're going to solve for x on this one. So you use cross multiplication. So you'd have x squared equals 80. I take the square root of both sides. Am I just going to say that x equals square root of 80? Is that going to be my answer? Am I just going to plug square root of 80 in it and give me a whole decimal? No, we aren't going to do that on the test. We're going to lose points for that. We need to find what perfect square goes into it and simplify. Mary, you had your hand up? Did you? 16 goes into it. How many times does 16 go into it? 5 times. So we can rewrite this as square root of 16 times square root of 5, which is just 4 times square root of 5. My next one says find the geometric mean between 9 and 12. That means I put 9 as one of my extremes and 12 as the other. It doesn't matter what order you really put them in. You could put the 12 up there and the 9 on the bottom. But we cross multiply and we come up with x squared equals 108. Real quick, I'm going to make, it's not really a mistake. It's just I didn't go quite far enough. Pretend like I made a little bit of a mistake. Not really a mistake. It's just not completely finished. I went to my calculator and I did 108 divided by 4. And then I did 108 divided by 9. And I said to myself, hey, 9 goes into it evenly. And I stopped there. All right, I stopped at 9. All right, so I took this square root. I said x equals square root of 108. But then I stopped at 9. So I said x equals square root of 9 times the square root of 12, which would equal 3 square root of 12. Is that fully simplified? No, it's not. Is it a little more obvious that it's not simplified here? So by dividing by that 12, or by that 9, I'm going to realize that I have 3 square root of 12, which can be simplified further. Am I going to take points off because you simplified it twice? No, I'm not going to. All you got to say is, oh yeah, it's not simplified all the way yet. All right, and it's not simplified all the way because this is going to equal 3 times square root of 4 times square root of 3. Square root of 4 is 2, so it'd be 6 square root of 3. All right, so sometimes we just don't quite finish it. And if you would have saw 36 went into it, you'd been good right there. But I didn't, so we just went with that. Okay, so always once you have it simplified, just double check to make sure some small one doesn't go in. Like 9, 4, or 16. Something small doesn't go into it. All right. Recall that when we had a right triangle and we drew an altitude, we created actually 3 triangles. We created the big triangle, and we created 2 smaller triangles off the side. But in order to use those triangles, generally we had to write them as similar triangles. We basically redraw them in a proper order so that they're all facing the same direction, that each side matches up with its side. So that could be a little cumbersome, because it'd be nice if we could just write it like this, but in fact we'd have to rearrange these so that our right angles are all on the same side and that our proper sides match up. That way we could say something like triangle ACB is similar to triangle ADC. We could also say that triangle ACB is similar to triangle CDB. And finally, we could say that triangle ADC is similar to triangle CDB. So we needed to redraw those in order to say those 3 statements. Because we say those wrong vertices out of order, you're no longer correctly stating which triangles are similar. We're just going to do one of those triangles down below. Because we've already done this, we've already taken a test on it. So we're just going to do one triangle. So let's cross out B. Because I don't want to take our time up just doing that. Alright, so we said if I have an altitude, which we have, because it goes from a vertex to the other side and it makes a right angle. So that is an altitude. X is an altitude. It creates 3 triangles, 3 similar triangles. So what I'm going to do is I'm going to draw 3 triangles that are pretty much the exact same shape. And then all I have to do is label them. And then I'll know how everything compares. All right, big one's easy because it's already written. That would be G. It will be E. Why did I write an H, though? That's perplexing. It's an E. It's an F. And from G to F, it's 4. From E to F, it's 5. And from E to G is 3. So I have they basically gave it to me. All right, let's go ahead and draw. Let me highlight it really quick. We'll do this guy in yellow. We're going to do that triangle next. Well, if we look at G, that is our right angle, so I want to have my right angle right here. Which letter, H, G, or E, is my right angle on my next triangle? Mary? H. It's a tough question, right? All right, now what we're going to do is we're going to ask ourselves, which angle do they share? In other words, which one can I use the reflexive property on? E or G between these two triangles? Which one share the entire angle? So is G the exact same, or is, yeah? What was that? E. So if you notice, E is the exact same angle in both triangles. Whether it's the little triangle or it's the big triangle, E is the exact same angle. So I want to put E in the exact same place. So that's my E, which there's only 3 choices, so that must mean that my G is over here. And that makes sense because I only took part of G. Right? G can't be the exact same thing because I only took part of it. So they share E, and now we have this. Now we just put down the information I know. Well, X is H to G. H to G is X. And we also have E to G is 3. I don't know what E to H is. It has something to do with 5, but we don't know what it is. All right, our last triangle. We're going to do, let me highlight it in, let's do red. Let's just do red for the fun of it. I think this is too big right now. There we go. So we're going to do this triangle. And the easy one is our right angle. Our right angle for this one is going to be H again. Now, once again, we're going to ask ourselves, do they share F or do they share G? In other words, is F the same in this triangle and this triangle, or is G the exact same angle in that triangle and that triangle? Yeah. F is going to be the same. Because if you look at the big triangle, I have F. And the small triangle, I have F again, the full angle. So that means wherever F is in my big triangle, I want to have it in my similar triangle. So that's F. And that means my other one is G. Now we label anything we can. H to G is X. And G to F is 4. So the whole point of this is that we can kind of forget about this. Now we can just use proportions to solve for X. Now, there's multiple things we can do. So we can note that 5 is proportional to 3, just like, let me circle it, 4 is proportional to X. And if I went all the way across the line, 5 is proportional to 3, and 3 is proportional to 4. And just real quick, I'm going to also state that 3 could be proportional to X as well. Those are all the things that are proportional to each other. What I'm going to do is I'm going to do that 5 over 3 equals 4 over X. We've done this plenty of times. 5 goes to 3 the same way 4 goes to X. We also could have did 5 goes to 4 the same way that 3 goes to X. Either one of those would have been the same answer. All right, now we just cross multiply. Cross multiply, which give me 5x equals 12. Divide both sides by 5, and we have x equals 12 over 5. That's a decimal, so I'm just going to leave it as 12 over 5. Kind of cumbersome, isn't it? Having to redraw stuff over and over and make sure I did everything correct. We're going to use the geometric mean to simplify this process. We will no longer have to redraw triangles. And we are going to use 2 methods. Note that these methods only work if I have an altitude. Yeah, we have a bunny ears and a heartbeat method, but they only work if I have an altitude, which means I come from one vertex and I go to a right angle over here. So don't do it on every single triangle. Only works, maybe put a big note somewhere on there that only works if there's an altitude. Only works if there's an altitude. So heartbeat method. We're just going to write our steps down first, and then we'll talk about what they mean. Well, step one, I'm going to go from A, that looks like a triangle. I'm going to go from A to D. Then I'm going to go from D to C. Then I'm going to go from C back down to D. And then I'm going to go from D to B. Why is this the heartbeat method? And why? Yeah. Just like what you drew. And why does it help us? So first we're going to draw the heartbeat. First we're going to draw the heartbeat that Chris just did with his hands. So if I go from A to D, it looks something like that. From D to C goes up. C to D goes down. And it goes back here, just like a heartbeat on a heart rate monitor. Boop, boop. Boop, boop. Boop, 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 boop. All right, so it gives us a heartbeat. And how we're going to use that is our first step was to go from A to D. So the first thing we're going to write down below is, why did I do that? We're going to write A, D. All right, the second step I did was D to C. So right underneath that, I'm going to write DC. My next step was to come back down, C to D. So CD. And finally, I have D to B. This method, we're going to use this if there is a term on the altitude. So use use if term is on the altitude. In other words, if I have a number or a variable on here, I can use the heartbeat method. So we're not going to do an example really quick, but I'm just going to show you when you can use it. I have an 18 on my altitude. That's going to tell me to use the heartbeat. I have a y on my altitude. It's going to tell me to use the heartbeat. Over here, I have an altitude, but is it numbered or labeled or anything? So it's going to tell me I can't use the heartbeat. Because if I use the heartbeat method on this one, I would go from here to here. Do we know that length? Do we know this length? Do we know this length? So my heartbeat method would have I don't know over I don't know equals I don't know all over 16. I can't solve that. I don't know if you can. That's a lot of I don't knows. So in a method like this where it's not labeled, we're going to use something called the bunny ear method. And the bunny ear method is a bit of a stretch. It kind of looks like bunny ears. All right. That one looks like a heartbeat. I like that one. Bunny ears are just, you can picture them. But this is our steps for bunny ear method. We're going to go from A all the way to B. All right, so that means I'm going to go all the way from A to B. So whatever that length is, we're going to have that. That's the full length. All right, then we're going to go from from B to C. So that kind of comes up here. Now we're going to kind of repeat that. We're going to go from C back down to B. And finally, we're going to go from B to D. And we kind of have bunny ears. It'd be better if you had to go all the way back here, then we definitely have bunny ears. But we can't go, we already covered that line. So it's just B to D. They're kind of bunny ears, right? There's at least one bunny ear there, right here. One got bitten off, I guess. And was really, maybe it's just, dang, I don't know. It's the bunny ear method. The long and short of it is I have to go all the way across, B to C, C to B, and then B to D. And this can help me get any number that's inside of these, all right, if I don't have my altitude drawn. So let's talk about what proportion that makes. Well, that's going to make, my first step was A to B. Then I went from B to C. That's going to equal C to B. And finally it goes from B to D. I want to note something. Is D to C any different than C to D? Is length D to C any different than length C to D?
No.
No, this is 4, this is 4. If this is 3, this is 3. These numbers are always the same. All right, so if you did it correctly, these numbers should always be the same. Or the variable, if this is x, this is x. This is 40, this is 40 in both cases. That's how it's going to tell you if you're doing it right or wrong. All right, let's do some examples of this. All right, we already said this one has an altitude. We also check to make sure it has an altitude. And it's labeled. So we're going to do the heartbeat method. We're going to go, boom, that's 12. So we have 12 over, we go up, that's 18. That's going to equal, coming back down is 18 again. And then we go all the way over, and that's y. And I didn't have to draw any triangles whatsoever. All right, so that's going to give me 12y. We're going to have 12y equals 324. Which gives me that y is just going to equal 27. And even though this one's upside down, we're going to do the same method. We're going to do the heartbeat method, and you can do it in the head without even drawing, but we're going to go from 5 over y, then y over 8. Do you think you can do it backwards? Do you think I can go 8 to y to 5? Yeah, doesn't matter where you start. All right, you can go whatever order you want to, as long as you have a starting point. You go up the altitude, down the altitude, and back. Doesn't matter which direction you go. All right, so I'm going to do 5. That was my first step. Then I went to y. That equaled y over 8. If I cross multiply, I'm going to get y squared equals 40. What perfect square goes into 40? What perfect square goes into 4D? What perfect square goes into 4? Lauren? 4 does. So y equals square root of 40, which is the same thing as square root of 4 times square root of 10, which equals 2 times square root of 10. All right, these two have altitudes, but they are not labeled. I don't need anything to do with them, so I can't use the heartbeat. Like I said, the heartbeat would just mess me up. So I'm going to use the bunny ear. And would it make sense for me to bunny ear over here and go here and come back? No. So it's going to tell you I'm going to go this direction. I'm going to go that direction. So I'm going to go from here to here, which happens to be length z. So we'll actually write z. Over, I come up. That's 27. That's going to equal, well, I got to come back down, because we know those two numbers have to be the same. 27, 27, and finally I have to finish with that 16. All right, I cross multiply and I get 16z. That's going to equal 27 times 27, which just so happens to equal 729. If you do the division, it comes out to an awful fraction, so I just put it as a decimal. A very rare case where I'll put it as a decimal, but it's 45.5625. I should have just picked up better values. Oh well. The important part is that we can draw it and draw our fractions. All right, number 7 has an altitude, but it's not labeled. I want to get to this side, so I'm going to draw my bunny ears in this direction. So we're going to go from here all the way over here. Now be careful. Be careful, because some of these are going to just label this as like 6 and this is 2. Remember to add this length to this length. They already did it for us, so it's 8. The full distance is 8. So our first step is 8 over x. Well, I already know my next one has to be x. But if I draw my picture, it confirms it. And then it's over 2. Cross multiply, we have x squared equals 16. Square root both sides. I come up with x equals Fizor. That's a cool way to say 4. I don't know if you guys know that. If you want to be cool, that's how you do it. All right, our next one, I actually have to do 2 different methods. Because my heartbeat method works with the 12, and my bunny ear is going to work with the y. Now, it's going to tell me which one to do first. Because if I do the bunny ear method, I have an x included, and I have a y, which is going to be tough to solve. So I'm going to do my heartbeat first. I'm going to do my heartbeat method first, which tells me you can start from either side. I'm going to start from this side. I'm going to go, well, I have x. We got x over 12. That's going to equal 12 over 16. Got my heartbeat. There's only one variable in there, so it's definitely solvable. So we're going to say 16x equals 144, and that comes out to a nice even 9. X equals 9. So this x right here equals 9. My next one I'm going to do is bunny ear. So I'm going to bunny ear from here to here. What number am I going to write for that? Mary?
25.
I'm going to write 25, yeah. So it's going to be 25. Yeah, Mary.